Welcome to the deep dive. Today we're really digging into Git. You know, the version control system that basically runs modern software development.
Yeah, it's everywhere. And we want to look at why. It wasn't an accident, right? Its architecture was, well, deliberately built.
And how its role, or maybe the role of the Git expert, is changing with AI now stepping in.
Exactly. So our mission here is to unpack that. Git's design, Linus Torvalds, really set out to make the anti-CVS.
The anti-CVS, what did that mean in practice?
Well, it came down to like three main pillars. First, proper support for distributed workflows, which was huge. Second, really strong safeguards against content corruption.
Ah, the SHA-1 hashes.
That's the one. Using cryptographic hashes means the content is the ID. It makes history immutable, verifiable, something older systems just couldn't promise.
Right, so that's integrity. What was the third pillar?
High performance, speed was critical from day one.
Okay, let's talk about the distributed model, the DVCS aspect. Being able to branch and commit offline. What does that tell us about Git's architecture compared to, say, Subversion?
Oh, it tells us everything. It points to the core structure.
Yeah.
The directed acyclic graph, the DAGI.
The DAGI, right.
Yeah. History is this graph of linked commits. And a branch, crucially, isn't some big server-side copy like in SVN. It's just a tiny, lightweight pointer. It moves around easily.
Lightweight, are we talking?
Like 41 bytes, just a file with a hash in it. That's why creating a branch is basically instantaneous and enables what people call disposable experimentation. It changed everything for collaboration.
Okay, so cheap branching helps workflow. But you mentioned performance, Git's famous for speed. How did Torvalds manage that, especially with this talk of snapshots versus deltas?
Yeah, that debate, it's kind of a false dichotomy, really. Git is clever about it.
How so?
Conceptually, logically, it thinks in snapshots. Full copies of the project stated each commit.
Yeah.
That's why checking out any old version is super fast.
Yeah, okay.
But for storing things efficiently, especially over networks, it uses something else. It bundles objects into compressed pack files. And inside those pack files, it absolutely uses delta compression.
Ah, so it finds similarities between file versions to save space.
Exactly. So you get the speed benefits of the snapshot model conceptually, but the storage efficiency of deltas physically. Best of both worlds, really.
That makes sense. And when you compare that to the old ways, like SVN branching there was slow because it was literally copying directories on the server. Right?
Painfully slow.
Yeah.
A totally different cost calculation. Made branching something you avoided unless you really had to.
No, Mercurial was closer, wasn't it? Another DVCS.
Very close. Technically quite similar in many ways. But Git had, I think, a key architectural edge. The staging area.
The index.
Right, the index. That lets you carefully craft your commits, make them really atomic and logical. Mercurial didn't quite have that same mechanism.
So was that the deciding factor? Or was it something else?
Honestly, while the tech mattered, the knockout blow was probably the network effect. GitHub just exploded.
Right. GitHub basically made Git the default.
Pretty much. It became the standard. But interestingly, not for everyone. Perforce, now Helix Core, still holds ground in certain areas.
Yeah, like game development, animation, big studios seem to stick with it. Why hasn't Git taken over there?
It comes down to handling massive binary assets. Think, multi-gigabyte textures, 3D models, things you can't really merge.
Okay.
Perforce is centralized, and its core strength is managing these huge files with built-in file locking. Everyone knows who's working on that giant texture file. Git. Well, Git needs Git LFS, large file storage bolted on.
And that's just not as seamless for those workflows.
It's generally seen as less integrated, less robust for those specific, very large binary workflows, yeah.
Okay, let's pivot. This is where things get really interesting now.
Okay.
AI. We're seeing AI tools automate Git tasks.
We are. Things like suggesting commit messages just by looking at the Git diff, or even helping resolve merge conflicts. It's doing the mechanical stuff.
So what can't it do? What's the limitation here?
Well, the fascinating thing is current AI is great at very localized, context-specific tasks. It can see what changed in the code pretty well. But it has zero high-level understanding. It doesn't get the why. It doesn't know the business goal, the project strategy, why this feature matters for the next release. It lacks that broader context.
So the human role, it shifts from doing the commands to something else.
Completely. You're moving from being the command executioner to being the strategic overseer, the orchestrator, if you like.
The orchestrator of AI-driven development.
Yeah. And maybe even more importantly, the curator of the project's history. With AI potentially generating a lot of code, maybe lots of small commits.
All right, it could get noisy.
Exactly. The human expert's job becomes using tools like Git rebase or squash merging to distill all that activity into a clean, understandable narrative. You're preserving the story, the why, not just the what.
So it's less about knowing every Git flag and more about understanding the project's evolution.
Precisely. And that means focusing on different skills like really high-impact code reviews, looking for architectural issues, subtle logic flaws that AI might miss.
Things that require that deeper understanding.
Yes, and also championing good documentation. Because ironically, good human-written docs are fantastic context for AI tools like Copilot to actually work better.
Interesting. So documentation feeds the machine that helps us.
In a way, yeah, it's all connected. The big picture is AI integration doesn't make the Git expert obsolete. It transforms them into this strategic steward for the whole DevSecOps pipeline.
Making sure all this speed and automation actually leads to better, more robust software in the end?
That's the goal.
Okay, so let's leave our listeners with something to think about. Here's a final thought for you. Maybe the real bottleneck in AI-driven development isn't the AI's power, but the quality of the strategic story, the history, that only a human expert can curate and preserve. That history is what ensures speed actually translates into meaningful progress.